This is a 11.55 question from the textbook, and I would like to talk a little bit about how to strategically solve this problem. So when you look at this problem, it's pretty wordy, right? You can't see or imagine how the circuit will look like, but the good news is that you can actually start putting everything together by going through this description of the problem. So a balanced three-phase delta connected source supply power to a load consisting of a balanced delta in parallel with a balanced Y. So which means that if you will have to draw this picture, it will look something like this. You have a load, and then you have a phase impedance, and then in this case you have a delta load, and then a Y load. So this will look something like this is a ZY, and then this is a Z delta. So the phase impedance of the delta is 24 plus J 12. So for that Y, you have to convert that into the Y connector. So as I say that every time when you put information, no matter what kind of topology would be delta Y, Y delta, delta delta, or Y delta, Y to Y, you're going to convert everything into a Y connected configuration. So it's good to have this information written in this way, right? So what we have here is the first Y and the second Y. And the first Y, just mentioned that is a delta, so you have to convert the delta to Y in this case. Then you have to, I think this is going to be a ZY2. So the second load, so the first Y load G is that you can convert that into Y connected. That means 24 plus J 12 divided by 3 will be the final number, which is 8 plus J 4 ohms. So that's the first impedance information for first load, and then the phase impedance of the Y is 12 plus J 8. So this will be just 9. So for J Y2 will be just 12 plus J 8 ohms. And the rest of the ABC phase sequence source voltages are this, and as you know, this is already in given. And then the line impedance per phase is 1 plus J 0.08 ohms. So you can just say that this G line is equal to 1 plus J 0.08 ohms. So the question asked is find the line current and the power absorbed by Y connected load. So which means that is this Y connected load. So I'm going to use this highlight to emphasize on what they are looking for. This is the second question, and the first question is to find out the line currents. So the line currents and the power absorbed by the Y connected load. So you will have to find these two information. The line currents would be this as well. So unlike the exam question that were asked before, you were given the receiving end voltage. In this case, is the other way around. So you know that the sending end voltage would be this. This is the sending end voltage. This is a line voltage, not line to neutral. So you will have to convert that information from line to line to line to neutral. So this is a phase voltage. So the first step you have to do here, change the color here again. The first step will be find out the equivalent circuit here. So that parallel load. The equivalent. Equivalent circuit. So once you find out the equivalent circuit here, then you know the impedance information for the receiving end. You know the line impedance. You know the voltage here. To find out the current of the phase A, the I, so that will be simply the next step. Second will be IAA will be equal to VAN over the total impedance, right? But the VAN here is not the same as the VAN here. So because this is a line to neutral, remember when we convert everything to Y connected configurations, this is going to be line to neutral. This is going to be Y connected. This is going to be the line current. So you have line current, phase voltage, and then Y connected load. So this guy has to be converted into from you have to find out how to convert VAB into this. So make sure that you know how to use that positive sequence of the voltage conversion, and it should be divided by square root of 3 because the line to neutral, the phase voltage, is actually shorter than the line voltage. So that's the second step you have to do. So once you find out the VAA, which is the line current, what you can do the next step is you can find out the other two line currents. Two line currents for B and C. So we use this throughout the semester. The convention, how we do it is a small letter A, and capital A indicate the receiving end. So this is consistently used throughout the chapter 11. So once you find out 1, 2, 3, what do? Remember, you have to find out the first part is find the line currents, right? And then the power absorbed by the Y connected load. So that will be referring to the second one. In order for you to do that, you have to find out the 3 line currents. So this is a first question, right? And then once you find out the 3 lines, the next step will be you have to find out the voltage at the receiving end, right? Which is simply using the voltage division. So you know the source of the current, so that simply means that the ratio of the total impedance, and then the denominator is actually any of this impedance. So since we already know the equivalents from the step A, you can just say that the Y2 in this case will be the equivalent, so that's ZY1. So and then multiply by the V source, and that gives you the V receiving end, right? So once you find out the line current, you find out the phase voltage at the end, receiving end. Then to find out the power absorbed is simply multiplied by the 2. And make sure that you know what you're going to do here is that because you have Y connected load here in this situation, and the second one is actually Y connected, so we are good to just simply use a S equal to VI conjugate to find out what will be the power absorbed by that load. Or alternatively, you can actually use the resistor value of this load multiplied by the current going through this. So that will be the so we are going to deal with 3 phase, right? So that means that you have to multiply by 3 in order to find out the power absorbed by the Y connected load. So that's what will be 3 phase So that means you have to use the p might be equal to 3 times I square r of the zy2. Hope this helped.